How's it going, and welcome back to my tutorial series on NumPy and NumPy arrays. Today I'm going to go ahead and walk you through some of the basics, some of the kind of starting concepts it's useful to know as you start to learn and dive into the NumPy library and start working with and interacting with NumPy arrays. So to start with, we're going to go ahead and just kind of import our NumPy library as NumPy. If you haven't installed it, you can go ahead and also you could go ahead and run this command, pip install NumPy. As long as you have your content environment running and you have some sort of Jupyter Notebook launched, or you can do that from the console, you'll be able to install the NumPy library. So to kind of move on to kind of some of the important attributes that I kind of would like to highlight, and it's important to understand the nature of these attributes as you start working with things. And I know I've had a few gotchas myself as I started to, and as I was learning and working through these things, that I think it would have been important to understand these concepts to begin with before actually diving in. So kind of the first method of the array is ndim. So how the arrays work is, like we kind of talked about in the introduction, is there are these data structures that hold different values in them for us, and they all have their own they all have the same homogeneous data type and size and memory. So basically, if you can look at this as like similar to like a list or like a vector, right, of values, normally numbers, and each one of those. So like, let's say it's just one dimensional array, or just kind of like a normal Python list. It's going to have just one axis or axis, right? So that actually only has one dimension. And as you start to create higher dimensional arrays, they have multiple different axes, then the dimensions obviously go up. And so one of the methods you can call, so let's say I created an array. So I have my array there, which is just one value. I can go ahead and call array.ndim, and that'll give me the number of dimensions, or the number of axes in my array. So this one's a 1. If we were to go ahead and let's just make up a random array, and let's make this a higher dimensional array. We're actually going to make it into a 2-dimensional array. Call it ndim, and then you get 2. So kind of see how that works. And then the next important attribute to know, and something that's really useful and I use all the time when I'm working with these arrays, is the shape. So go ahead and call array.shape, and this tells you, so important thing to know is that NumPy arrays are row column indexed, right? So the first thing that you'll look at is the rows. So the first axis is the rows, number of rows, which you see we have 2 here. And then the second one is the columns. So this stands true for when you're calling on the shapes. And then also when we get into actually indexing the arrays, you want to make sure that you remember that everything is a row column format. So rows first and then columns. And then the next method that's really, attribute that's really good to know about, is the array.size. So all this does is returns the number of elements we have in our entire n-dimensional array. So here you can see that we have 2 rows of 5. So obviously the product of that is 10, and that tells us our size. This also comes in useful if you don't want to, a lot of times, like, so there's certain instances where you want to, let's say you have an image that you've read into a NumPy array, and you have parts of it that you want to mask out. It's kind of nice to be able to compute some sort of statistics by just taking, the amount of areas you want to mask out divided by, the size of the array to get your percentage of the image that is bad or good, right? So kind of a simple use case and where that comes in handy. And then the next important attribute is the data type. So this is really important, especially when you start reading in arrays from different data sources, like off of imagery or different types of binary files, stuff like that. It's really important to make sure that you have and you understand that what data type your array is, and then you also understand that when you create an array of a specific data type, that it can affect the different types of values you get, the values that are held within the array. So a good example is an unsigned integer 16 is the value range is 0 to 65,535, right? So a NumPy array of data type unsigned uint16 can only hold values in this range. So if I were to say, let's say that I'm going to call my array up here. We'll just go dtype equals numpy.uint16. And then now I want to go ahead and take my array, and let's say I want to take the first index and set it to something that's outside of that range, which is -1. So what happens is if now I go to access that particular, actually I access the entire dimension. But so if I go and access that same dimension, it didn't set the array of values there to -1. It actually set them to 65,535. That's because it defaulted because the value I wanted to set it to is outside of the range of the data type. So this is really important when you start manipulating and reading in different types of arrays. If you don't know exactly what data type it is and you're trying to set different values, it's not going to return the value you want, and it's not going to hold the values you want. So something to pay a lot of attention to and to make sure you're aware of as you start to manipulate things. So what I could do in this particular instance in order to deal with that is I could be like, I want to create array 2, which equals array, the first array I created, dot as type, let's go int 64. Oh. Okay, and then I were to access array, the first axis, and then we set that to -1, and then we go ahead and call array 2, and see now that we have the correct data type, now you're able to set it to -1 because that's within the range of values for that data type. Okay, so the next kind of thing that we kind of want to talk about, so we've kind of covered how you can call these different, each array has these different attributes, and you can kind of see how they might come in handy. You have the data type, you have your size, you have the number of dimensions, and you also have your shape. And then kind of an overview of the different types of things you can do to arrays and do with arrays is within the NumPy library is you kind of have the basic array creation. So here's kind of a list of some of the different operations which we're going to kind of dive into once we get into creating arrays. I'm going to go ahead and go through all of these different built-in methods. So you have arrange, array, copy, empty like, and things of that nature. You also have array conversions. So like you saw me do up here, I converted this first array into a different data type by calling .asType and then passing the data type I wanted the array to be converted to. That's another use case of that. Manipulations, so you can, because there's the different axes, once you get into higher dimensional arrays, you can do different things like column stack. You can concatenate two arrays on one particular axis. You can find the diagonal of an array. So if you have a two-dimensional array, something like this, you can find the diagonal values. I think those have to be a square array though, I'm pretty sure, but I might be wrong on that. And horizontal split, horizontal stack, vertical stack, ravel. So if you have a higher dimensional array, so we know that array 2 dot ndim is of 2. Well, if we do array 2 dot ravel, it unpacks those different dimensions into one dimension, and it just creates one dimensional array out of a higher dimensional array. And then we can go ahead and take a look at ndim here. We can see it's 1. So different types of operations that kind of come in handy. You can also index and what they call here asking questions of the array. So you can index NumPy, let's say NumPy dot where array 2 is equal to 0. And what this does is it returns actually a NumPy index, so where you can now take that and index arrays with the return of this conditional, right? So the next thing you can kind of do is kind of do different types of operations revolving around choose, compress, cumulative sum, inner, ndarray.fill, put, and then get. I think get one is also one. And then you have other types of mathematical operations where you get into the statistics where you can compute the mean. So you can go numpy.mean of array 2. You get 0.5. And then you can also compute dot products between two different arrays, and then other types of linear algebra types of operations. So just kind of a basic overview of some of the important attributes you should start learning and start understanding about NumPy arrays before you start working with them. Basically, that you need to know that the row column indexing is the standard for NumPy arrays, and whenever you're dealing with higher dimensional arrays, you need to make sure that you're being able to index them, obviously from the row and then from the column, and then you can also access certain things like their shape and their different levels of dimensions and stuff. So I hope you enjoyed. I hope this was a good kind of overview on some of the basics of NumPy arrays, and I will see you in the next one.